Hi guys, welcome to your channel DNA. So let's today focus on the OSPF lab. We have around three area 7, area 6 and the area 5. And we have another area, we call it as a backbone area 0. So currently we have area 0 in between ABR1 and ABR2. Why we call this router as ABR? Why? The reason behind it, one interface is connected to the area 0 and another interface is connected to the area 7. That is the reason we call this router as a ABR, area border router. So for theory or for deep dive, please my refer deep dive video. So here we are only focusing on the configuration part. So let's start with the ABRs, right? ABR router. So let's first configure the ABR router 1. Log into the router, ABR router 1, ABR router 1, configuration terminal, router, OSPF, and then process ID. Process ID is a 16-bit ID, start from 1 to 65535 question mark, right? 16 is a process ID and process ID is a locally significant. Even though both OSPF router have a two different process ID, it doesn't matter. Still you can able to form the neighborship. Process ID 10, then router ID. So what is router ID? What router ID is unique identifier. Router ID is a 32-bit IP address. You can configure manually, or if you have a loopback IP address, so loopback address become a router ID. The last way, if you have not configured manually, if you do not have a loopback, the highest IP address of active interface become a router ID. Right? So now in this case, you have a two interface on ABR1. One is a gigabyte 0/2 having IP address 10.7.1.3 and gigabyte 0/0 having IP address 10.0.0.1. So which IP address is the highest? So 10.7.1.1. So if you will not configure router ID manually, what will happen? 10.7.1.1 will elect as a router ID. The first sequence is manually. If manually is not there, then router will look for a loopback address. If you have a multiple loopback address, then highest IP address of loopback address, right? It become a router ID. And third is manually not found, loopback not found. Simply your router will select a router ID from its active interfaces. So highest IP address become a highest IP address of active interface become a router ID. So let's go and configure the router ID over here. So router ID is 1.1.1.1, which is the ABR1. So now as soon as I configure the router ID 1.1 manually, it will take precedent. Perfectly fine. So end and hit a command show IP protocol. Here you go. Now you can see the routing protocol OSPF 10 processor 10 and your router is 1.1.1.1. What is the next step? So now define the interface or define the area and add interfaces into the area. There are two ways to configure it. Number one, you can go and configure directly on the interface. Under interface, you can define IP, OSPF, process and area ID, or here on the router protocol prompt, OSPF 10, here you can configure the network command. Whenever you enter the network command, make sure you have to consider network ID of your interface, not an interface IP address. And network ID will followed by the, or I can say network ID should be followed by the wildcard mask. Correct? So now network ID is here 10.0.0.0, then wildcard mask 0.0.0.3 and area 0. See, here you go. Now router will identify where is this network 10.0.0.0. Okay, it's directly connected to my G0/0 interface. It means G0/0 is now part of area 0. This is the one way. Perfect. You can configure the area on interface. Another way is go on interface gigabyte 0/0, and here you can add command IP OSPF 10. 10 means area, not area ID, process ID 10, area 0. Once you enter the command, automatically this interface will be now participating in the area 0. Create, correct? Okay, hit enter. Okay, so let's follow this way only. Then go to the interface gigabyte 0/2. Let me zoom in. Perfect. Now this interface gigabyte 0/2. So gigabyte 0/2. Now we are inside the interface. IP OSPF process ID 10, area ID 7. So now what happened? This interface connected to the another router is a part of area 7. Correct? So now you have done with the ABR router 1 configuration. Okay. So let's go and configure the ABR router 2. See, if you configure everything only on single router, but you not have any configuration on your connected router or neighbor router, so OSPF neighborship won't come up. Why? Because it's required a bidirectional communication. Both routers or all the routers in the network should support the OSPF and should enable the OSPF. ABR router 2. ABR router 2 configuration terminal, router OSPF 10, then router ID 1.1.1.2, right? And there is an option you can configure the network command here, network command, right? Or you can go on interface and assigned interface under area. So sorry, my bad. Exit interface gigabyte 0/1 IP OSPF 10 area 0. As soon as I hit enter, I'm expecting neighbor should come neighborship between the ABR 1 and ABR 2 should come up. Here you go, right? Perfect. And show IP. How to see the neighbors? Show IP OSPF neighbor. I can see the neighbor. And what is the network neighbor ID? 1.1.1, which I have configured manually on ABR01. Clear? We'll discuss in the detail what about this full state, date interval, address, and your exit interface. Great. So let's go back and configure router 7. Configure a router 7. Enable configuration terminal interface. First configure the router OSPF 10, router ID 1.1.1.7. This is the router ID of router 1 area 7. Okay. Now this router has a two interface. One is connected to the ABR, another connected to your LAN network. So what we will do here? No problem. Gigabyte 0/0 is also part of area 7, and gigabyte 0/2 is also part of gigabyte 0 slash gigabyte 0/2 is also part of area 7. Clear? Okay. Then exit interface gigabyte 0/0 and 2 IP OSPF 10 area 7, exit and interface gigabyte 0/2 IP OSPF 10 area 7. Here you go now, guys. What happening now? Now your neighborship with the ABR1 is come up. Show IP OSPF neighbor. But we have added this interface as well in the area 7. So why there is a no neighbor found on interface gigabyte 0/0? Why? Because this interface is connected to the LAN. This interface is not connected to the any router or any OSPF enabled router. Clear? Yeah? Chalo. So then as soon as the neighborship between the ABR1 and the router 1 area 7 is up, definitely this router will advertise the connected subnet, right, to the ABR, and further ABR will advertise it to the ABR2. Okay. Now look at ABR2. We have only configured one interface, which is gigabyte 0/0. What about the other interface? Gigabyte 0/2, gigabyte 0/0. Now gigabyte 0/0 is connected to the multi-access network or point to multi-point network, or you can say multi-access network. Correct? Because we have a three routers: RTR1 area 5, RTR2 area 5, and ABR2 gigabyte 0/0 interface. Gigabyte 0/interface IP address 10.1.1.1/29. Here we have IP address 10.1.1.2/29, and here we have IP address 10.1.1.3/29. Means these three IP address belongs to the same subnetwork. Clear? Okay. Let's go and configure the ABR2. Where is my ABR2? ABR2. Configuration terminal interface gigabyte 0/0 IP OSPF process ID 10 and area 5. Then another interface I have gigabyte 0/2 IP OSPF 10 area ID. I think 6. Yes, 6. Okay. Now you will not see any neighbor. Why? Because you have not yet configured the other router. So let's do one thing. Let's first configure these routers. Right? Two routers. So one interface, two interface, zero interface, one and two interface. Okay, is a part of area 5. Enable configuration terminal router OSPF 10 router ID. What's the router ID? Okay, 5. 5.5.5.1 means router 1. Okay, exit. Then go to the interface gigabyte 0/1 IP OSPF process ID 10 area 5. See, as soon as you hit enter, definitely your neighborship will come up with the ABR2. Okay, 0/1 is connected to LAN. Wait. Configure the gigabyte 0/2. Gigabyte 2 and hit enter command. Same command IP OSPF area ID process ID 10 and area ID 5. Yeah, here you go now. You can see the neighborship with 10.1.1.2, which is your ABR. Now the neighborship between the this router 5 and ABR now is up. Clear? Then configure the RTR2 area 5 router. Here how many interfaces we have? 0 and 1. 0 and 1. Configuration terminal router OSPF 10. Then router ID 5.5.5.2. Correct? It's a second router. Yeah, 2. Exit. Interface gigabyte 0/0 IP OSPF process ID 10 area 5. Exit and 0/1 IP OSPF area 5. Same command. Clear? Here you go. Now you can see two neighbors. How two neighbors? Right, from here you have a neighborship with this and this. Why? Because all the interface connected or participate in the multi networks having in the same subnet 10.1.1.1, 1.2 and 1.3. That is the reason this router discover the two neighbor. One is the ABR and one is the RTR1 area 5 router. Clear? Yeah. So go and look at the configuration. Show IP OSPF neighbor. Enter. See, you can see the two neighbors here. But you can see the two status BDR and DR. Means designated router and backup designated router. We'll discuss in detail in our next chapter or next session. Okay. Come to the configuration of RTR area 6. These RTR area 6, right, having a two interfaces. 2 and 0 belongs to the area 6. Very simple. Configuration terminal router OSPF 10 router ID 1.1.1.6, right? Enter. Then exit. Interface gigabyte 0/0. Correct? IP OSPF 10 area 6. and we have another interface 2 IP OSPF area 6. Here you go, guys. Now you can see the neighbor, right memory. So show IP OSPF neighbor. Yes, I can see the ASABR is my neighbor. So guys, so let me, okay. Now this RTR1 have LAN subnet 10.7.7.0/24. This subnet is in the area 7, right? And this 10.6.6.0/24, these subnet is in the area 6. So tell me, for area 7, area 6 is a inter area route? Of course, yes, because this 10.6.6.0/24 is not belongs to my area 7. And vice versa, even though for area 6, area 7 and area 5 routes are a inter area route. Okay, so in the routing table you will clearly see the OIA in front of your route. OIA means OSPF inter area route. Clear? So let's see. Show IP, my bad. Show IP route OSPF. Here you go, guys. Now on a router 6, you can see the area 7 route 10.7.7.0/24 via OIA. OIA means OSPF inter area route. OSPF inter area route. Right? Now this router 6, no, these routes are not belongs to my area. So if I would like to reach other area route, I have to first reach out to my ABR, area border router. Clear? Right? So now based on the neighborship, see now look, focus on the neighborship. Neighbor ID means nothing but a router ID, right, of your neighbor. Stateful means there are states. Please refer my earlier video, a deep dive video, where there are different states: down state, init, two-way, start, exchange, loading, and full. Now full state means everything is shared between the, or everything is every routes, every subnets, and every database, LSDB database share between these two neighbor, that is showing as a full state. Dead means 40 seconds is a dead interval, right? 10 is a hello interval, 40 is a your dead interval. Correct. IP address of the neighbor means this is a neighbor, this is the router ID of your neighbor router, and this is the IP address of interface IP address of your neighbor. Look at here, 10.6.1.1. Yes, here you go. 10.6.1.1 is configured on a ABR router 2. So of course, now I know the neighbor IP interface IP address. So what I will do, whatever routes I receive from this neighbor, simply I will put the next stop address. This IP address as a next stop address. See, look at here. Clear? Right? And this interface means this is neighbor interface or your local interface. Yes, it is my local interface. It is not a neighbor interface. It is my local interface, means exit interface gigabyte 0/2. It's not a neighbor interface. So this information is a neighbor router ID. This is the neighbor interface IP address. This is my locally significant, not locally significant, local information. And this is my, again, date time is again local. Clear? Right? If you look at the show IP OSPF neighbor, see 31 second, 30 second, again reset to 39. Why? Because after every 10 seconds you are receiving the hello from your neighbor, so it will reset your date timer. So 31, 30, reset, 38, 37, 36, 35, 34, 33, 32, 31, 30, reset. Right? Why? Because after every 10 seconds you are receiving the hello from your neighbor. If you lost 4 consecutive hellos 40 seconds, then what will happen? This router 6 will declare this neighbor as a dead. Clear? Right? Now go and look at the routing table of ABR. ABR 1 or ABR 2. Look at the ABR 2, right? Because it has a multiple area. show IP route. So if you show IP route OSPF, alright. So for ABR, this 10.5.1, 10.5.2, right, and 10.6.6, these are the O route, and OIA 10.7.1 and 10.7.7, these are the O route. Why? Because see, for ABR, this 6.1.1 and 6.6.0.0/24, it is directly connected. Why? Because ABR is also participating in the area 6, but this ABR2 doesn't have any direct link with area 7. So for this ABR2, these area 7 routes are OIA routes. Now if you look at the ABR1 show IP OSP show IP route OSPF output, so for this router, this 10.7.7.0/24 and 10.7.1.0/30, right, is locally O route, but this 6.6.6, then this 10.5.1.0, 10.5.0 are the OIA route. Why? Because this ABR is not currently directly participating in the area 6 and the area 5. There is no direct connected legs or interface to the area 6 and 5. Clear? So let's see. Show IP show IP route OSPF. Oh, you can see only single route. What is happening over here? Show IP route. Show IP OSPF neighbor. Yes, you have a neighborship with 10.1.1.2, which is APR, and 10.1.1.7, which is your this router, but you are not able to do any route from area 5 and area 6. It's strange. What could be the reason? Okay, so let's, I think, quickly reboot the router. I don't see any issue. As expected, you should receive the route. Yeah, here you go, guys. After reboot the both router, I can able to see the all the routes belongs to the area 5 and area 6. Clear? So why we are not able to see the why ABR2 showing areas 6.10.6.6.0 and 10.5.1.0 and 10.5.2.0 as a O route OSPF intra area route. Why? Because ABR is ABR interfaces are participate in the area 5 and area 6. But for ABR1, all routes belongs to the area 5 and 6 is OI route. Right? Because this ABR1 doesn't have any leg or any interface with area 5 and the area 6. Clear? O means OSPF intra area route. OI means OSPF intra area route. There are different types of route as well. OE1 or OE2, OSPF external type 1, external type 2. So we'll see later when we will have the ASBR in our network. Clear? Okay, thank you so much. Bye bye.